Okay, so in this problem, we want to determine the resultant moment of all of these forces about point A. So I've got these three forces. I've got 250, 300, and 500 in these specific directions at these specific locations. And what we're going to do is find the moment of each force about point A and then sum them together. So starting with the force 1, the 250 Newton force. First thing I notice is what I'm going to do is I'm going to take this force, I'm going to break it into two components. My vertical component and my horizontal component. The horizontal component goes right through point A, so it contributes no moment to the moment about point A. The vertical component is the perpendicular component of this force about point A. That's my cosine of 30 component. Now, this force puts down, it creates a moment going in the clockwise direction about point A. So it's a negative moment. And that moment arm is 2 meters away in the negative direction, with the perpendicular component of the force being 250 cosine 30. So that moment is negative 2 times 250 cosine 30. Negative 2 being the moment arm, 250 cosine 30 being the perpendicular component of the force. So the moment of that first force about point A is 433 Newton meters. Okay. The second force, okay, break that up into its horizontal and vertical components. The horizontal component, again, that would be cosine 60, goes right through point A. So it has 0 moment contribution about point A. The vertical component, that would be the sine of 60, okay? That's the perpendicular component. It has a distance, a moment arm of 5 meters, okay? That vertical component acting down here creates a clockwise rotation as well about point A. That's a negative moment about point A. 5 feet away, 300 sine 60 is the perpendicular component. So I get negative 5 times 300 sine 60. That's the component, or the moment of the 300 Newton force about point A. And that's negative 1,300 newtons, or 1299. Now, this final force, I'm going to break it into its two components. I've got 3/5 times 500 horizontally and 4/5 times 500 vertically. Now, both of these components are creating a moment. So we'll start with the vertical component. That would be the 4/5 times 500. It's going to be 5 meters away. It's acting down. That creates a clockwise rotation, a negative moment about point A. So I would have negative 5. Again, that would be the 5 meters, 4/5 times 500. So I go negative 5, okay, 4/5 times 500. Okay. Now, the horizontal component, that's the 3/5 component, okay, that is a perpendicular distance of 4 meters away. Now, this moment, heading to the right, creates a counterclockwise rotation about point A. That would be a that would be a positive moment. Counterclockwise is a positive moment. So it's pushing this way, creates a positive moment about point A. So that would be positive perpendicular distance of 4 meters times 3/5 of the 500. So summing up each of those components, I get negative 800 about point A for that 500 Newton force, force 3. So the resultant is just the sum of each of those. So negative 433 minus 1299 minus 800 gives me a total moment of these three forces about point A to be negative 2532. That would be Newton meters. And again, I just break each force up into the components, figure out which is the perpendicular component, and use that to figure out the moment of each one, then sum up each moment to figure out the total resultant moment of those three forces added together.